Hi everyone, today I'm going to go over the Lab 7 activity worksheet. I have the worksheet pulled up over here, but I'm going to be working on a separate sheet. All the functions and all the instructions are the same, same with the values. I just figured this would give us more space to show our work. To start, we have our main function over on the top left, highlighted in gray. Below that, we have our function that we're going to call from main right at this point. And then I also prepared our stack for us. Note that these values on the left are our memory addresses, and then these values on the right are the values that the memory address corresponds to. Okay, and notice that the difference between each memory address is by 8 bytes. So you'll see that we're subtracting, there's a difference of 8 bytes each time. Another important note, these are our instructions. So we have push, pop, call, ret. So I'll go over how each of these work more in depth as we go through the problem. But you should understand that when we're pushing, we're going to make more space on the stack by subtracting RSP. So we know that the stack grows towards the lower memory address. And if we have 0x0 up here and we have 0x32 here, and if our RSP is right here, if we want to make more space on the stack, we have to subtract 8 from RSP so that RSP can make more space on the stack. So we're going towards that lower address over there. And then pop is essentially doing the opposite. If we do pop and we have our RSP right here, we're essentially going to go down towards the lower address. Okay, and we'll go into call and ret later. So let's look at our first instruction in main. We know that we have to first push RBP. Pushing RBP includes two important instructions: subtracting 8 from RSP, and then moving the value of RBP into the value that the memory address in RSP points to. So let's look at our values for RSP and RBP. Right now, RSP and RBP have FC158, which are the same values. If we look at our stack, we can see that that's right, this memory address right below. So let's show RSP and RBP pointed right at the same address. So RSP has 0xFC158. The first instruction, remember, we have to subtract 8. So we're going to subtract 8. Minus 0x00008. Remember to pad. 8 minus 8 is 0. And then the rest of the numbers stay the same. So now RSP is equal to 0xFC150. Let's look for that space on the stack. Okay, we see that the memory address right above RSP is going to match this value over here. So now we're just going to move our RSP. We're going to move our RSP up here because this is the value in RSP, and our RBP stays the same. Okay, our next step, we have to move RBP into the parentheses RSP. So what is this doing? This is basically dereferencing for us. So first, we have to go to RSP, find its value, which is FC150, and that memory address points to some value over here, and we're going to take whatever RBP is equal to and place it in this space. We're not changing the value in RSP, we're changing the value of the memory address of RSP that it points to. So this is going to be 0x000FC158. And that's how push works. This is important because our stack is going to grow and it's going to shrink. But at the end of the day, when we change our RSP value and as our base pointer goes up, we need a way to be able to return to our original base pointer. And that's how we do this, by storing it over here. Okay, we're done with our first instruction. Let's go into our second instruction. In this case, we're moving RSP into RBP. So RSP, which is FC150, now RBP is also going to be equal to that value. So now RBP, which was pointing at, or which had 158, will now be pointing over here at the same value of RSP. Our next instruction, we're going to move 23 into EDI. Remember that EDI refers to the last 4 bytes of RDI. So that means we have 4 unknown bytes of RDI, and then the last bytes of EDI. Well, we have to pad with 0 because they only give us 1 byte over here. So we have to pad with 3 zeros, 3 bytes of zeros, and then that last byte will be 23. And we're going to fill in these first 4 bytes with asterisks. Okay, that should be 4 bytes of asterisk. And that's our step for EDI. Okay, now what are the values at this point? So at our first checkpoint, we know that RBP and RSP both have the value of 0xFC150. We know that EDI has a value of 0x23. And for our RIP or RIP address over here, our RIP register over here, RIP basically has the address of the next instruction. So if we're at this instruction right now, RIP will have this instruction inside it. So since we're checking the values at this point, we know that RIP will have the next instruction 54628. So RIP will have 0x54628. And that's the address of the next instruction. Okay? Now we're going to do our call instruction. And this is where things get pretty interesting. For call, we know that we need to first subtract 8 from RSP. So RSP right now equals 0xFC150. So let's subtract 8 from that. 0x8. 0 minus 8, we can't do that, so we have to borrow from 5, which becomes 4. This becomes 16, because we're in the hexadecimal system. 16 minus 8 is 8 in hexadecimal. Then 4 goes down 1 CF. So this is our new value of RSP. If we look at the stack, again, 8 bytes less than its current address, so RSP is going to go up by 1, and RBP will stay the same. The next step is to move the return address into, again, we're dereferencing, so that means we have to go into the value of this memory address. So in here, we're going to put the return address. But how do we find the return address? Well, we're going to go to our call instruction, and we're going to grab the address of the instruction right below it. Because when we go to call a function, we're going to add a new stack frame, and we're going to manipulate the stack in that function. But eventually, when we leave that function, we want to find a way to go back to the original function that had called that function. And this is what the point of that return address is. So after the function that we call, we're going to go back to this instruction, and the address of that is 54632. So our return address is going to be 0x54632. Okay. Then the final step of call is going to be jump to that label. Well, in this case, our label is 545FA, which matches with this label here, which will be the first instruction of our new function. So now, instead of going to pop, we're actually going to go jump to this instruction. Let's check our values at this point now at area 4. So we know that RSP is at FC148, RBP is still at the same point, 0xFC150, and our RIP, it's not going to be the next line, but it's going to be the first line of the function that we're calling, which is 545FA. And our RDI register stays the same. So this will be area. Now let's start inside our function. The first step is to push RBP. Again, we're making space on this on the pointer or on the stack. So 0xFC148. This should be easy. If we're subtracting 8, it just becomes FC140. This is RSP. So now RSP has FC140. We're going to go up when we subtract 8 bytes. Then we're going to move the current value of RBP into this space. So RBP is FC150. So we're going to do 0x FC150. That's the push instruction. Next, we're going to move RSP into RBP, which was at 150, is now going to be at 140. So RBP will also be at 140. Now we've moved RSP into RBP, and now they're both pointing at the same address, FC140. And now we're going to subtract 16 from RSP. So 16 in hexadecimal is 0x10. We know this because 16 in binary is equivalent to 10000 because this is 2 to the 4th, and that becomes 0x10 in hexadecimal. So then we're going to subtract 0x10 from the current RSP, minus 0x10, pad with the zeros, 0, 3, FC130. So now RSP will have this value. So now RSP, which was at 140, is now going to go down to 130. So our next step is we're gonna move RDI into minus 8 RBP. So minus 8 RBP doesn't actually change the value of RBP. It's just using RBP to access other values within the stack. So if we do minus 8 RBP minus 0x RBP, this is the same as subtracting 8 from 0x FC140. So we're going to get 38 FC1 0x so 0x FC138. So at that address we want to have move RDI. So that's going to have RDI inside it. If we go up here, we found FC138, and now we're going to move RDI, which we already know the value of up here, into that space in the stack. So this becomes, we don't know the first 4 bytes, so we're not going to fill that in. 1, 2, 3, 4, and then 0, 0, 0, 0, 23. So that's what that instruction is doing. It's not changing the value of RBP, it's just accessing some space above or below it using this type of memory addressing. Okay, our next step is to move 1 byte FC into minus 2 RBP. So let's calculate that address. So we know RBP right now is at 0x FC140, and we want to subtract 2, 0x2, and then we get 16 minus 2 is 14, which is E, 3E, and then we get 1CF 0x RBP. Well, when we look at our stack, we know that none of these really match the addresses, but we know that since we're subtracting 2 from RBP at this point, it has to be somewhere in this row, right? So we know the way that our addresses work. 38 refers to this spot over here, the last byte. Then we have 39. Then we have 3A. Then we have 3B, 3C, 3D, and this is 3E over here. So we're only changing 1 byte at 3E. So this is actually going to become whatever this value is over here. So this will become FC. Maybe I'll use this color so you guys know. Okay, now our next step is we're going to access minus 0x10 RBP. So RBP, we have at 0x FC140 minus 0x10, 0 minus 0, 0, 4 minus 1 is 3, 1 CF 0x. So FC130 we know is right here, and the value that we're placing in there is going to be 4312. 0x 4312 And the reason I'm making space over here is because we will be working with this value later on, and we might be changing some values in the full value. Okay, now our next step is that we're going to move a byte 7f into -e RBP. All right, now let's go find that address 0x0000e. We can't do 0 minus e, so we borrow 1 from 4. This becomes 16. 16 minus e, which is 14, becomes 2. So we get 32. We have 1, c, and f. So again, we look at our stack. We don't see this address, but we know 30 corresponds to this byte over here. This is 31. So then this must be 32. So starting... So right here, we're moving 1 byte, 7f, into that spot, 0xfc132, so that will become 7f. Let me clean that up a bit for you guys. Okay, we're almost done. So now we're moving 1f into EAX. Remember that EAX is the last 4 bytes of RAX, so RAX, we don't know the first 4 bytes. I'll just do one big asterisk for that. But we know that EAX now has, it has 1f. So 0, 0, 0, 0, 0, 0. That's EAX. Okay, what are the values at this point? Before I write down those values, I also do want to, okay, so we know that our value for RSP at area, what is this, area 3, is going to be 0xfc130. RBP is going to be 0xfc140. RIP, well, if we're at this point, we know that the next instruction is going to be right here. So it's going to be 54614. And then the values of RIP or of RDI and RAX are the same. Okay, at this point, we're going to add 16 to RSP. So we're going to restore its original value. So if we're at this is our RSP right now. If we move 8 bytes up and then 8 bytes up again to the higher memory address, RSP is going to be at FC140. Okay. And now we have to pop RBP. So what are the instructions involved in popping? Well, first, we have to move whatever the value of the memory address in RSP is. We have to place that in RBP. So RSP is at its address, or its value is FC140, but that points to FC150. So now RBP is going to equal 0x FC150. FC150 is all the way down here, so now RBP is going to be right down here. Okay? And then we have to add 8 to RSP. RSP, which is at 140, is now going to be 148. So that means our RSP is going to be right down here. Okay? And now we have to return. Return means that we have to add 8 to RSP one more time. So now RSP, which was at 148, is going to be at 150. And then we're going to remove the -8 RSP into RIP. So let's go look at what -8 RSP is. Well, first, we know that RSP equals 0xfc150. We want to get the address that's 8 bytes less than it, which means we're going to go up over here, and we want to get this value. So now we know that minus 0x8, it's going to be fc148, which is pointing to 0x54632. Remember, this was our return address from earlier. So now we're going to place this value, which was our return address, and now RIP is going to be 0x54632. This means that the next instruction we execute is going to be this. So now, once we've completed our pop and return, we're going to go all the way back over here. And then now we can finish our main function. And that's basically the end of this problem. From what I see, I actually think area 4 is supposed to be after you call. So after you call, I'm assuming it wants the values after we've done this function. So I'm going to update area 4 to be the updated RSP and RBP and RIP. So we know RIP is going to be this pop, which is 5 or 0x 54632. RBP is going to be at 0x FC150 as well as RSP. All right, so that was the Lab 7 activity worksheet. Thank you for watching, and I hope this video was helpful.